incidents in OpenObserve. What I'm telling you here that with this feature, it basically takes minutes since your alert fires to getting you a root cause. And we're going to show you today how that works. We're going to show you how you can do that in your own data. But before jumping to the demo, what I want to speak about is that what are the benefits or why we are building this, okay? Okay, we talked about how this helps us save a lot of time, which is actually wasted in normal scenarios. And there's another big factor, which is the RCA quality. So I often see RCA report, or if I ask an engineer, we had an outage in the morning, how did we fix that? We just get a reply that I restarted a pod, restarted a service, and it fixed it, which I think we can all agree it is more of a confession than an RCA analysis. So before showing you how the SRE analysis looks like, what we want to run you is the old way. If there were no incidents, there was no AI which was running, there was no OpenObserve SRE agent which was automatically analyzing your data and producing the root cause, what you were doing during an incident in a normal scenario. So we might have folks who are not very familiar with OpenObserve UI. So I would like to quickly mention a few things here. This is an OpenObserve instance where we do not have incidents enabled. So this is an older version which I'm running. And if you log in into cloud service, or maybe if you self-host OpenObserve, this is the home screen which you land on. Okay. Here you see a bunch of metadata about what data is being ingested in this OpenObserve instance. You see what alerts. There are a few other components. If you look on the left-hand side, right, you see there are the core observability features, logs, metrics, traces. We have real user monitoring. And then, of course, we have dashboards on top of it. We have reports, alerts. And this time we talked about from alert, right? We started from alert to root cause. So let's start with alert here itself. I'm in my alert screen. In OpenObserve, there are two types of alerts available. One is a scheduled alert and another is a real-time alert. So again, as the name suggests, real-time alert would be basically as soon as the data ingests, the alerts get evaluated at that moment. There is no gap in between. While a scheduled alert, it's basically that the same evaluation is running in a scheduled fashion. Here, for this demo, we have created a few alerts back in advance and see that it's an app unavailable. But let me give you a context of what data we'll be working with in the demo today. This is an e-commerce application. This is a sample e-commerce application, which is based on OpenTelemetry demo data set. I have also a few other components running in the background, like a database and an LLM service, just to make my data production ready. But this is the data which we'll be dealing with. And I see, let's click on this alert. Let's see what we have in here. Okay. So I see that it's a status code alert where it's responding to 500, any trace which is giving. So if I look at edit configuration, I will be able to see what data source this alert is configured on top of. So this is a trace alert. It's a scheduled alert. If we go ahead and look at what condition it stays, it's have the query condition where a status code is greater than or equals to 500. And all of us know that basically means that your service is available. Since we were talking about alerts, and when I get an alert notification, I already see this alert has been satisfied a few time ago. How I would go about is I would jump to my telemetry, which I have ingested for this particular service, right? So I have this data ingested in an OpenObserve in a stream named call. Okay. So I've selected this stream. I'm going to go ahead. I'm going to run query here. And I see a bunch of logs coming in. You can try looking into these logs real quick. I see there are a few attributes, cluster, there is a deployment, and I have this single namespace here, which all these services, this complete demo application is running. But logs does not tells me what is exactly happening with my application. And I cannot search in this heap of logs, right? I cannot go ahead and check. I can see there are a few info logs, there are different levels, and there are a few debug logs too. So I cannot manually go ahead and find a single log which tell me what's wrong. Why is my alert triggering? This is the same application which the alert fired, by the way. I come back traces. I'll go ahead and run a query once again. And you can see here, okay? if I quickly look at what traces I've got in past 15 minutes, let me actually do one thing. Let's change this to past 2 hours and let's just some more traces. Okay. I see that in the errors panel, I see a significant spike on somewhere around an half an hour ago. And I would actually, what would like is to actually see what's wrong here. Okay. What I can typically do is that I can click on this and I can find what alerts or what traces are containing this error messages. Okay. In OpenObserve traces UI, you would simply see that this particular trace, right? This contains two error spans. Once I click on a detailed view, it gives me this waterfall diagram. How I would typically do is that I directly see that there is something wrong here in the API gateway. Okay, let me take a step back and quickly talk what other service which you are looking at. Okay. So I was looking at the same trace earlier from like a 10, 20 minutes ago, where I have these different services. There's a user service, there's a database, there is an API in place. You also have the front end application. Once we try to debug which service is actually responsible, I see the error span starts somewhere from here. Again, we can dig down into these internal spans and it does tells me that it has something to do with database. Why? Because I can see that there is a database span at the bottom. Still, I came on the database. What I can try to do is I can look for some events or associated to this logs, or I do not have events. So what I can do is actually check this attribute. And here I would know that this operation is problematic to me.
You know what, Manas? Let me stop you right here. I get
Okay.
it. We all get it. The thing is, you are having troubles pinpointing the exact problem that we're facing right now. And that's the whole point of this thing. I cannot really see you suffer all that much. Let me show you and everybody what we can really do using our incident management system. Okay. Allow me to share my screen and show you how this whole thing would look like if we were, let's say, going through our incident response mechanism. Okay. So, what I will try to do here is show you how easy your life would become had you actually utilize the incidents feature. I'll start at the same place you did on the alert screen. So I have configured in my system two different alerts. They're all using the same kind of ingested data, the same synthetic data that you were using. And these two alerts, one of them is again error logs, the other is server errors. Server errors is simply HTTP status code 500, and the error logs is simply looking at log entries containing the word error in them. Now, naturally, we would expect if ingestion is going on, then clearly there should be some form of alerts should be triggered. Now, last triggered at this value has changed, which means alerts have actually been triggered. That also means that an incident should have been created. So on the left-hand side, Manas introduced you to a bunch of options on the left-hand side. But if you were paying attention, there was no incidents there. That was because in his instance of OpenObserve, he had actually deliberately disabled the incidents using a feature flag. Right now, I have it enabled on my device. But if I open this up, you would see the first thing right off the bat, you would see is a title that says server errors on user service. That essentially means server errors was the alert that created this incident. It was the first alert that fired when this incident was created, and it fired on user service. This is the name of the service that this was directly impacting. You also have the CBT, the status, and everything shown here, and also dimensions. We'll talk about dimensions in a short bit. On the right-hand side, you see a couple of actions like acknowledging or resolving. Obviously, you may not want to do that right away until you have run your analysis. So let's go through that. I'll open this up. And the first thing is this incident overview screen. A bunch of different items, total alerts, total unique alerts. So the same alert may fire multiple different times, as you can see on the bottom right of the screen over in this section. This is also something worth noting. On the right hand side, again, you see something called dimensions. We're going to come to why dimensions exist. Now, because we had 6 total alerts and we have 2 unique alerts, somebody might ask, how are we putting them together into one incident? So the idea is, if alerts share the same dimensions are nothing but their attributes, where they might be coming from. It could be a deployment. It could be, they should have certain variables in them. In this case, the deployment, the cluster, the namespace, and the service, these things, nothing fancy. You'll pick up those values, and if they're common among various notifications of alerts, you'll group them together. That's how simple it is. And once you group them together, you can actually go here and see that these things are put here together. They form a single incident. On the top, what you're seeing is the status, the severity, the count of alerts. There's an acknowledge button, there's a resolve button, and there is an edit button, which allows you to edit the incident's title, etc. Now, if I were to talk about a bunch of different other things, but I think the what we are most interested in right now is the incident analysis. But before we jump into that, let me show you a little something. This is called activity. Now, this gives you a sort of progression on how the incident has evolved over time. Multiple alerts could be firing, more alerts could be combining here. Somebody might come and comment, hey, what's happening? Okay. So if you do this, that also becomes logged into this. So more people can come in later and chime in. And this creates a nice context over time and makes it easier to handle. But the one that we're talking about most is the incident analysis. Now, if I go to the incident analysis, now notice this. We have not spent a lot of time since the alert fired, and it's already here because the AI SRE agent was running in the background. So instead of reading through all this, I'm going to show you some of the important pieces. Obviously, there's a summary, so you can quickly get a glance of what's happening here. But we also have the evidence and timeline. These things matter the most. Why? Because in case of, let's say, we have a user digging through this, for example, Manas himself was trying to do something, he would go through certain steps. Let's say you have a written down run book. You're going to go through logs, you're going to go through metrics and traces, you're going to correlate them, so on and so forth. We give that run book to the SRE agent and it goes through them. Unlike a human, it can't forget. It gives you the service dependencies, how the requests are flowing using something called a service graph. And in the interest of time, I'm not going to talk about the service graph today, but essentially it's another feature that OpenAI has that that forms a topology of all the services that your telemetry data contain. Now, you can have distributed traces, you can have log patterns. This one's particularly important because if your system is functioning optimally, you may not see a lot of logs, maybe less than 1%, a lot of error logs, that is. But if your system is behaving abnormally, those error logs would suddenly increase to maybe 10%, 50%. It could be anything. That percentage matters. We can look into those things as well. We have metrics analysis, we have other contributing factors, and then we have impact assessment, actions, and future insights. The benefit of this is we all know that this data that we're looking at, this is 100% synthetic. The LLM doesn't know it. So even if your data was a real data, this was running in a real environment, the analysis would be equally serious and equally on point. So it gives you some immediate steps for quick remediation rather than maybe just restarting the service, which we all know maybe solves the problem for the immediate moment, but doesn't really close it for the future cases.
Escape.
And then you have some future issues as well. And then you have a nice little executive summary that can be shared with maybe other devs, maybe your manager, maybe the other stakeholders as well. But you might ask, and I'm sure Manas, you might be thinking right now, what gives? Why should I have to trust an LLM? Considering all the problems with hallucination and whatnots, how do I know this is reliable? Now, you don't have to take my word for it. You certainly don't have to take what the LLM is saying as gospel. What you can do is jump into logs straight away. Now, these logs, you never had to filter for anything. You never had to search for anything. These logs were prepared for you on its own using, guess what? The dimensions, which we initially extracted. So that's why dimensions are so important. And I mentioned them in the beginning. You take dimensions, and instead of manually searching through those, you go through logs, you go through traces, and you go through metrics. Okay. So this can show you spikes, drops, everything. Okay. Now I'm quickly going to show you that this is identical to what Manas did, except we didn't have to do any of these at all. So this was the error span that we had at the time. I'm going to open this up. And as you can see, this is the exact same span that Manas had earlier opened in his screen. And that is the power of this thing. By the time I came in, I opened this up. This had already done all the analysis for me. So what remains is you can go to incident analysis. You can look at the actions, and you may either use your own discretion and take maybe a slightly different course of action, or maybe just use this. But the the one major problem it solved for you was you didn't have to spend half an hour, maybe 2 hours investigating through the problems, investigating through tons of data while you were still half asleep.
Using OpenObserve, they can go ahead, try it in their own setup. You just need to add your AI provider API key. And there are two ways to configure that. We would recommend using our official Helm charts. There are already configurations in place. You just have to enable it. And once you do that, there are also some different components like an AI gateway, and there's a configuration for enabling incidents particularly, and the RC analysis in your OpenObserve instance. Once you do that, you should have the SRE agent service, like it's our own deployment. I believe there are two components to it, Shraddha. If you can just confirm that.
That is correct, Manas. One of them is the core OpenObserve service, and the other one is the SRE agent service, which contains only the AI workload.
Cool. I think this is great. And again, we have the Docker repository available for the SRE agent. You guys can yourself, if you have to deploy the SRE agent yourself in more configurable or more customized fashion, you can use this. But feel free to try it out. Again, as we said, we welcome all the feedback which you guys can bring. Thanks for watching, folks. If you have any more questions, feel free to join our Slack community, follow us on LinkedIn and other social media platforms. Thanks again.